In this video, we're going to talk about chemical kinetics. Now, before we can really get into the kinetics, we need to talk about collision theory. And it's quite amazing that reactions even take place when you think about what has to happen in terms of the molecules. So you have to have multiple molecules, and those two molecules must collide. So they have to run into each other. Not only must they run into each other, they need to be properly oriented during that collision. If they're not, then they're not going to produce the correct products. Now, they have to collide, they have to be properly oriented, and they must have enough energy so that the collision results in a chemical reaction. Here is a view of ineffective and effective collisions. So we have NO reacting with NO3, and we're forming NO2. Now, if they are oriented in this direction, then we have two oxygens that are going to collide, which means we would form a bond between the oxygens. So this would be an ineffective collision because it's not going to give the appropriate products that we're desiring. Here we have an oxygen colliding with one of the nitrogens. However, it's the oxygen from the NO. And so we're also going to have an ineffective collision because they're not oriented correctly. In our next example, we have the two nitrogens colliding. And this orientation is not going to give us what we want because we're forming a bond between two oxygens. The new bond is going to be between the oxygens. So it will also be an ineffective orientation. In this next example, we have the new bond being formed between one of the oxygens and the nitrogen. However, this would give us two NO2 molecules, but not in the way we want them. So we have to reorient the NO so that we get the proper orientation. And that will give us an effective collision. So there's only one orientation with these two molecules that's going to lead to an effective collision, which then can lead to an effective reaction. The rate of reaction is how quickly the reaction is going to take place. It is generally defined as the change in concentration of any product or reactant per change in time. So, how quickly is your reactant going away over time, or how quickly is your product forming over time? And the rate of the reaction can depend on several conditions. So it can depend on temperature. Remember, if we increase the temperature, our molecules can move faster, which means there's going to be more energy in those collisions. We can manipulate the concentration. If we have more molecules, or so a higher concentration, then there is more likelihood that they're going to collide. And then we can have the presence of a catalyst. So these are just some of the conditions that can change the rate of a reaction. Now, a catalyst is something that speeds up a reaction by lowering the activation energy. In other words, it provides a different pathway for the reaction to take place. So the activation energy is the minimum amount of energy required for the reaction to take place. So remember, not only must two molecules collide, they must collide with the proper orientation and they have to collide with enough energy. And that energy is the minimum amount of energy needed to result in the effective collision. And that is called the activation energy. We have energy diagrams that show this. So the activation energy is the difference between the energy of the reactants and the highest most energy level. So E sub A is the activation energy, and here is the activation energy for a reaction. And this is just a generic reaction. The red path is the uncatalyzed reaction. So the activation energy is this energy right here. In the green path, we have a catalyst, and we can see that the activation energy is much smaller. So if you don't need as much energy, then the reaction can go a lot faster.